Happy day to you all. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Today, we are taking a topic under mathematics, and that topic is called ordinary differential equation. What is ordinary differential equation? Consider these parameters I'm going to put down. The topic, but before we do that, the topic is ordinary differential equation, ODE. Ordinary differential equation. Ordinary differential equation. So ordinary differential equation is the type of equation that relates the derivatives of function together with one or more function, that relate derivative together with one or more function. Like for instance, let me say I have the y dx. I can relate it to one or more function of x, like in this format. So this kind of relationship is an example of ordinary differential equation. What I have here is called the derivative. So in ordinary differential equation, derivative is being related to one or more function. Like for instance, if we have the y dx, which is the derivative, I can relate it to f of x. I can equally have a scenario whereby I can relate the y dx with f of x and g of x as division. So differential equation consists of the derivative and also functions too. Now let's do this work. Let's say you are given this equation, y is equal to a squared. In this equation, a is called arbitrary constant. Arbitrary constant. Y is called dependent variable. Dependent variable. Yx is called independent variable. So the question can say find its differential equation. So you are given the equation y is equal to a squared. You are asked to find its differential equation. Now this is how we are going to do it. The equation given is y is equal to ax squared. So the derivative of y from the standard workings is that we use the power to multiply these coefficients. We have 2ax, then we subtract 1 from the power, so now have y prime is equal to 2ax. Now we want to make sure that we remove the arbitrary constant, because the essence of solving differential equation is our ability to remove all the arbitrary constants. We can see that in the question given here we only have one arbitrary constant. So because of that, the number of the order of differentiation will be 1. That means we are going to differentiate once. Now I can make this a subject to a formula here and then substitute it here in the original equation. So I have y prime divided by 2x is equal to a. So by substituting a back into the original equation, we have y is equal to y prime divided by 2x then times the x squared. You can see that the x that is down cancel one of the x that is up. So now have y is equal to y prime times the x y prime times x. So we can this is y prime. When you cancel these two, we have a we have y is equal to y prime times x divided by 2, because one of these x will cancel this x. So by cross multiplying, you have 2y divided by x is equal to y prime. So what we have here now is a differential equation. That will be our final answer for this kind of a problem. So another problem is this, for clarification. Let's say we are given y is equal to a cos ax plus b sin ax. We are asked to find its differential equation. Now if you look at this problem, we can see that there are two arbitrary constants, and that those constants are constants a and b. So these are two arbitrary constants, Since we are having two arbitrary constants, it means that we are going to find second order derivative. That is writing like the square y over the s square, which is written as y prime prime. So that's what we are going to find for this problem. So what we are going to do now is to solve this problem and then see how the differential equation will look like. Now let's start the problem. We are given y is equal to a cos ax plus b sin ax. So before of all, find the first derivative, which is the first order. We have y prime. We remember that differentiation of cos will give us minus sign, so we are definitely going to have minus there. But what we are having here is cos ax, not cos x. So we use this as to multiply what is outside here. So we are going to have aa, then sin ax. Then for the second one here, we know that when we differentiate sin x, it will definitely give us a cos x. But in this case now, we are not having sin x, we are having sin ax. So we use this a to multiply the b. So we are going to have ab cos ax. So but because we are having two arbitrary constants, capital A and B here, then we are going to find the second derivative, which is called the second order. So that we are going to repeat this process the second time. So we now have y prime prime. Y prime prime also means the square y. Please take note of that. The s square, that's the meaning. The square y, the s square. So when we differentiate that, we are going to have minus a square cos ax minus a square b, that is sin ax. So now we can see that minus a square, this small a square, minus of it is common here. We can factorize it out. So we can now have y prime prime will now be minus a square into brackets. We will be left with a cos ax plus b sin ax. So here now, since this particular expression that I have here is the same thing as the first expression up there, far up there, that means the expression I have here is actually the same thing as y. So therefore I'm going to have y prime prime is equal to minus a square y. So y prime prime is equal to minus a square y. So this will be the differential equation of the original problem given. So I'm going to stop at this junction. Please do not forget to share, like, subscribe, and click on the notification button to have more of my video. Have a nice day. Bye.